As you guys go through your reading for this week, I want to just kind of pick out some topics that I think maybe would need a little bit more explanation, or maybe have been a little bit unclear if you're not used to reading this type of thing. So the first thing I come across in the reading where I think you might appreciate some clarification is that very first MATLAB code showing kind of the first steps of Gaussian elimination. This is on page 136 in your book. So what they're showing you here is if you have this augmented matrix where you have A augmented with B, the idea is for the first step in Gaussian elimination, you want to use this A11 entry to eliminate everything underneath it, right? So get it to where you have all zeros below. Now, as you do that in each step along the way, you're also changing all of the entries on rows 2 through n. And the reason I want to go through this piece of the code is because when you're first looking at it, it can get a little bit confusing. You can lose track of the index or what the index means. And so just to kind of help you guys learn how to read these things, it's really helpful when you're reading these things, if you get lost in the notation, to take a step back and just look at a specific example or a simplified version of what you're trying to read, and then just understand that what they're saying with this kind of generalized matrix here that they're showing in the book is just kind of a bigger version of, or a more generalized version of a specific example. All right, so let's just run through a simple example of what's going on with this MATLAB code. All right, so first of all, we're doing a for loop, and we're running for I equal 2 to n. So we're starting at I equals 2, and we could continue doing this all the way until n. And what I want to do over here on the side, I've just kind of gone through let's talk through the first run through the loop. And then if we understand what happens on the first run through the loop, then you understand kind of what happens as you do all the rest of them, okay? So on our very first run through the loop, we've got I equals 2, right? That's where the loop starts, is 2. All right, so in this code, if I equals 2, then this number mult, M-U-L-T, short for multiple, it's going to be A21 divided by A11. So A21, that's the second row, first column. So that would be the entry 4. A11 would be the entry in the first row, first column. So that would be a 2. All right, so our first run through this loop, this number mult is set to 4 divided by 2, which is 2. Okay. So now mult is set to 2 as we go through and do the next line. The next line is where we start eliminating numbers. Okay, so we're going to take A2 and then this colon. Let's make sure you understand what that colon does. We're doing row 2 and then the entire or all of the columns. Okay, so we're not specifying a column. This colon means you're doing every single column. So if we're looking at row 2 and then that every single column in row 2, that means we're looking at doing this operation to every single entry in the second row. Second row, every single column. So what we're going to do is we're going to take some in each entry in that second row and subtract from it this number molt, which in this case is 2, times the first row, right? So A1 colon means you're doing the entire first row. First row and every column. All right, so just think about what this means. I'm doing the second row, so that would be the entry 4, or the row would be 4, 5, 6. And now technically that B2 isn't being taken care of in this line. B2 is taken care of down at the end. All right, so right now all we're doing is the 4, 5, 6 minus molt, which in this case is 2, times the first row. That's 2, 3, 1. All right, so that's the second row minus molt 2 times the first row. So that would be 4, 5, 6 minus 4, 6, 2. And so now what we've got is we're replacing that entire second row with what we get from this difference. We get 0, -1, 4. Okay, so just running through this line in the code, this is exactly what it's doing. It's just zeroing out the entries below that A11 spot. Our first time, remember this is just our first time through the loop, we're doing I equals 2. Our first time through the loop has zeroed out the entry directly below A11, and we haven't done anything to that second row yet. So that third row, 7, 8, 0, we haven't done anything to that yet. But then once we run through the loop, we go back through and bump I up 1. So then we do I equals 3, and we go through and do everything to the third row, and that would zero out that 7th entry in the third row. And then finally, the only thing we haven't done is B2 equals B2 minus molt B1. So in this case, that would be B2 minus 4 times B1 would be your new entry where B2 used to be. Okay, so all we've done is just one run through the loop, and again, after you've run through this loop and zeroed out this entry in A21, then you run through the loop again and eliminate A31, and then you've got that entire first column cleared out underneath that A11 entry. And that's again what they're showing here, is that after you finish this loop, you've got all zeros below, but then everything else below that first row has been updated according to this row reduction operation. All right, so that's just what's happening in the first step in Gaussian elimination. Now you can kind of guess, if you look over on page 137, you can write another loop that basically takes what you just did and repeats it on the remaining columns. Okay, so far we've only eliminated everything below that A11 entry in the first column. Next, you'll want to take this A22 entry and eliminate everything below it. All right, so if you look at the loop on page 137, there's two for loops. The outside for loop, that for j equals 1 to n minus 1, is telling you you're going to keep doing this process over and over again for every single column. We're starting with, we did it first with column 1, and now we're going to continue doing it for every column until we've eventually eliminated everything down to an upper triangular matrix.